Welcome back, dear friends. Finally, it's time to start working on some new projects. Having finally, I think after 9 videos, finishing the short Art Deco clock project. Well, it should be called the e-paper project with an Art Deco theme. So here the clock sits, because I've looked all around the house. I'm struggling to find any bit of wall or flat surface that's big enough to actually house that, so it's just sitting safely out the way. But I'm very pleased to say I think it is 12:15. Oh, how time flies. And it is Sunday the 31st of August, so it's working properly. So the next thing is to get on with the design of a smaller automaton head. More about that in a little bit. But I noticed that my 3D printer, bits of it were falling off, but little silicon bits around the print nozzle, and the fans haven't been working on cold days very properly. The bearings are going in the fans and other things. So in the end, dear friends, I splashed out on something. I was looking at buying, here's the original one, I was looking at buying a replacement nozzle, replacement fans, replacement this, that and the other. Because this one works, you have the spool of filament, that's PLA filament to you and me, that comes down, goes in there. There's a bit from the last time I printed. That's the stepper motor that drives it backwards and forwards as it's printing. It pulls it back, withdraws it a little bit when the print head is moving around to stop it stringing. Amazing it works at all, but the filament is pushed then through, fed through this long pipe and into the print head. And I got to thinking, well, rather than just replacing these bits, that's an awful long way, because the PLA filament is obviously flexible to a degree. It's going to have some sort of compression tension properties. I don't know what you call them. Well, compression, I don't know. Anyway, so it's not going to be that accurate, whereas this one, there's the feed motor for the filament, there's the long pipe, and that's straight into the print head. So I thought, why not give it a go? Because then when I'm printing all sorts of lovely little bits and pieces for me automaton head, I know that it's going to print really well, and this has served me, I think it's probably got to be about 6-7 years now without really very much being changed. And also this lovely pot, I think it was only about 25 quid. That's not bad, is it, for a NEMA stepper motor and all the rest of it. And a beautiful colour picture. I might frame it afterwards and put it on my wall, of the lovely circuit inside, the controller circuit, and how to wire up these new bits. Well, that's nice, most enjoyable. So we are, we've got the extruder stepper on that bit hanging over the front. That's great, it is working, and it's so much quieter with the new fans. As always, there's time for an aside. I contacted a plumber that my mum used to use just to get a recommendation, and he put me in touch with another plumber, and they both immediately told me when I said I wanted to replace an old-fashioned boiler, oh, your hot water cylinder won't be compatible, you'll need to get a new one of those and all the pipe work. And they obviously didn't realise that I'd plumbed this in, and I do know a bit about plumbing. I just thought this is rubbish. And luckily I've got a nephew who is a qualified plumber and Corgi registered, I hasten to add. And I said, how much would you charge to do this job? And he said, well, why are you getting other people to? I'll come and do it for you. So he did. So I didn't need a new storage cylinder. In fact, he didn't even go upstairs. He did everything just in this bit, this corner. Even it uses the original pump. Amazing. So beware if you get a plumber to quote for replacing an old-fashioned boiler with a condensation boiler, they may try and rip you off. Anyway, let's talk automaton heads. Here's one I prepared a very long time ago. This was the one that I used, or based the ones for the Is It Time for Tea Machine on. That's right, that was the first one. I'm going to design one, I think I said about 90mm high from the chin to the top of the head or something. And this time I want to make it simple, with the eyes moving and the mouth moving. I've used all sorts of different methods. I'm going to use 2 servo motors, one to twist it and one to make it look up and down. But I've ordered 50 of these little I'm getting all confused here. These little solenoids, so these things begin with the letter S. It's amazing. These are 5-volt ones, which is handy. Then designing a product using what you think are standard items, and then either finding that the price goes through the roof, or they change them slightly, or you can't get them any longer. It is a pain in the proverbial buttocks. So this way, once I've got it working, hopefully, I could then order, because they're much cheaper. I think they're £1.70 each solenoid, whereas the equivalent one that I used in the other heads to open the mouths, that's about £8. I've never understood. Well, I'm not. Don't get sidetracked again. That's the first thing. I've started with a solenoid and not much else. Right, so I started off by importing a head that I managed to download. It's the same head that I used for the Is It Time for Tea machine and the singing automaton. I dropped it into Blender, which I won't show you because I can't remember how to do it, and smoothed it out, because the original head had facets all over it that showed up on the 3D print, and someone kindly suggested put it into Blender because there's a tool. There's a tool for everything in Blender, it's so complicated to use. While it was in Blender though, look, the ears used to stick out more. So I remembered that when I was 3D printing them, they wouldn't print properly, because obviously as the thing's going round and round and round the printing nozzle, suddenly having an earlobe hanging in space, it just can't print it. So I used one of the tools just to sort of smooth in the edges. So that's nice. So we've got a head. I will go through this as quickly as possible, because obviously it's taken me days hunched over a hot computer. So we've got a head. So that's the first thing. Thankfully, I have saved for your delectation every single step. Also, it's a very good idea to do it like this, because, hang on, let me just paint this, because if you make a mistake, when you make a mistake, you know that you can go back and recover, so to speak. So the first thing I did was to slice it. First thing I did was to use the hollowing tool to hollow it out. You just click over the head, click on hollow, which is somewhere up here, and then tell it how thick you want the non-hollowed part to be, and it does it. And then I split it in half with the split tool, which is that one. Lovely. The next thing I did was to make it lovely and shiny. Look, shiny head. Isn't that beautiful? Because it makes it easier to see. The colours don't have any bearing on anything at the moment. So that's what we've got. I then used, because you can subtract objects, so I cut away parts of the inside. If you remember, there was a sort of the top of the mouth, the roof of the mouth there. Cut that away by simply, I won't go through this indefinitely, but introducing a large, whatever that's called, cylinder, and then I'll show you what you can do with it actually. Look, say you plonk it somewhere like that, and you can go subtract, edit, subtract, and then look, you see, isn't it clever? And that's so powerful. I love 3D Builder, because my brain can cope with the minimal amount of tools that it has, but they're so well designed that you can do so much with them. So yeah, we've got the mouth, sort of the inside of the roof of the mouth gone. Then I cut off this strange neck bit that was sticking out, because obviously I want the head to be able to look up and down. So I sliced that off and used a couple of cylinders to cut out that. It's nice because when you cut things out, the cut edge ends up the same colour as the object you cut it out with. Lovely. Right. I promise I'll jump ahead because there's about another 30 or 25 to go. So then I created a neck, a replacement neck that fitted in. I had to cut a little bit more away from there. I did it with a couple more cylinders and then hollowed out the cylinders basically to give it more of a neck shape. So that's nice, and again, all working in halves. We don't need to worry about the other half, hopefully. So there's the neck, and here's a neck pivot. Oh, a happy evening spent investigating, trying all sorts of things, different positions for this, working out where the neck should go, how high the face can look up and look down, adjusting, fiddling and farting about, because Blender is basic. So I know with, not Blender, 3D Builder is basic. I know you can get all sorts of CAD software that's very clever, and you can link things together. So I could link that together and just move that up and down to see what would happen with mechanisms. But you can't with this, which is absolutely fine. I count my lucky stars and thank my lucky stars that I have access to this type of software. It's amazing. I mean, growing up with big sheets of tracing paper and 2 dimensions only. I also slotted in a thing representing one of those solenoids, because I need to start thinking about how to get the mouth to open and close, just to give an idea. It is so easy when you're working on this to lose all sense of actual size in the real world. I know you've got millimetres and things on the base, but it really is quite easy to realise you're working at the microscopic level. Ridiculous, that tells you. Jumping on a little bit, I changed the neck a little bit, hollowed out some bits and pieces, also separated the mouth so you can see that is now a separate entity. Built a hinge on it, worked out where that could go, and a lever there, and hopefully gravity will always try and open the mouth, and the spring on the solenoid, a slightly better drawing of one there, will keep it closed. The solenoid goes on, that pulls in, that drops down. That's the theory. It probably won't work, but, you know, with the addition of some counterweights and things, it may be possible. Gives you an idea, though, doesn't it, of how the size we're working at. Because here's a solenoid. You think, oh, well, yes, you know, that's not very big. And then when you finally draw it, you realise, yes, it is. It's quite big. So we've got the jaw done, the mouth. Let's talk about hair. That embarrassing subject, not an issue for me. I purchased an STL file of a Victorian bob haircut. I even found there's someone who basically specialises in designing hair, which is really handy. I think I paid $4.50 for it. And I just thought that's going to be so worthwhile, because with the previous heads I have used real wigs because they were the right size for wigs. They're slightly bigger than this. And I discovered that Ziggy loved taking the wigs off the automatons and shredding them. So 2 wigs later, ruined. I don't know, I mean, obviously you could actually fashion them back into, restyle them, but I don't know anything about that. So the 3rd wig is on the Victoria, the singing automaton in the lounge, with a sheet of acrylic across it to stop Ziggy eating a 3rd one. So one of my constraints, or whatever, design things with this automaton kit, small automaton head, was to actually 3D print the hair, which is really handy. That's just brilliant. I was so pleased to discover this. And again, spent quite a lot of time adjusting the size, stretching and squashing, because, for example, if I select the hair, if you click on that one, you can change the size. You can, if you click on the padlock, change all 3 dimensions at once. So if I was to make that, say, 100, and click accept, look, it made it all bigger. And I've got a back button, which is lovely. So I've managed to do that, get it hollowed out, get it all sized properly, and obviously had to put the 2 halves back together so I could hollow out the hair. So we've got hollowed out hair. I then worked out where to put a servo motor. This is one of the little, what are they called? Tower Pro SG90. Really small in real life, really big. Yeah. So I've realised that I could put, I was thinking I was going to have to put the servo motor in the neck and link it up. But then I realised, of course, put it in the head. I've realised with previous heads that they're really front heavy. When you look at where the pivot is, all that mass there is going to be trying to pull it down. So that doesn't make any difference at all because it's right over the pivot. Never mind. But that's right, that's the other great thing about this hair. Look at it. That extends right back. So even if I need to sort of somehow drill some holes and put some lead in it or something, I can balance that, because that was a real problem with past ones. Then the next thing we need to do is to remove the eye So what I'm going to do, I have done this, but I'm going to insert just to show you how wonderful this is. I think I made that for the eye hole after some experimentation. I think that was about 16. So let's do that, and then we can move that up. Right, so we've got it in roughly the right place, and I can, there we are, you'll see there. So by fiddling around with this, I'm not going to now because I have done this, but just to give you an idea, then when we're happy with that, where it is, we can go to Edit, Subtract. And there we have an eye hole that's actually spherical, ready to receive an eyeball. A few steps later, and I had made an eyeball that's 1 millimetre smaller than the hole, and I realised this time, because before I tried to make an eyeball with a separate 3D printed iris that was just too small. It was ridiculous. This time I've realised, of course, that I could print the white bit with a hole in the middle, put a blue bit with a hole in the middle, and put a black bit into the middle of that. Absolutely perfect. They could even be printed separately in different colours. So we have an eye. Now, to this difference, I was thinking about using another solenoid, because with the previous automaton heads, I used servo motors to move them, and realised the number of times you blink something like once every 5 to 6 seconds, so it's a lot of blinking. And when you blink, your eyelids don't close slowly, they go down very fast and up again in milliseconds. So realised this time, just have the eyes closed open with a solenoid. Then couldn't work out any way of getting a solenoid on. By the way, there's a nice purple part that holds the mouth solenoid, so that's nice, and that just fits inside the lip, so that's lucky. Luck doesn't come into it. So I was thinking, how else could you open and close eyelids? I thought one of these little solar motors. They're called solar motors because they're small, use very, very low current, but they're pretty powerful. They're the ones I use on the motorised Kraken gauge kits. Lovely things. It will fit inside. I was thinking, you don't need it to go right round and round and round. Oh no, dear friends. It only needs, which it does, to go in one direction to open the eyelids, and then to turn in another direction to close the eyelids, and just stall. The motor can stall. Not very scientific. Anyway, more on that later. But you could use a little H-bridge driver. So, I mean, it means that the eyelids will stay where you put them, which is lovely. Otherwise, you'd have to have a solenoid on all the time to keep the eye open. Whereas with this, it's just, oh. So we did some work on that and started thinking about how we could... eyelids, that was the other thing, yes. Because we weren't going to... the royal we. I was just going to have an eye with an eyelid painted on it that would sort of swing up like I did with the first automaton. And I thought, no, John, you can't do that. If you're going to do a job properly, do it properly, overcomplicate it. So I ended up designing an eyelid, made the eyeball slightly smaller, so there's 1 millimetre between that. Then you have the eyelid there, 1 millimetre within that, and then 1 millimetre within that's smaller than the socket. So it should all fit together. And I thought to me, Sen, before we carry on down this road, it would be wise just to see whether you can actually print one of these, again, because of the sizes. So I split one up, put it onto a new 3D Builder document. I wonder whether I could print it like this. Now, you can obviously, with 3D prints, have the 3D printer build a support structure, which is lots of thin little bits of plastic that you can then snap out afterwards. But you never get a decent finish with those. And if you think about this, as it goes up, there's a curve. And it's amazing because because it's never printing into space, as the nozzle goes round, it can slowly build up. Verticals are no problem, and inner things are no problem. And the same with the circle, this bit. It's going out slowly, then it's going upwards, and now it's coming over. But as it comes over, the inside, if you think about it, is also curved. Will that be possible, dear friends, considering that this whole thing is 13 millimeters high? So I thought, well, let's give it a go, because if we don't want to go too far down this road if it doesn't work. So I tried it. And look, dear friends, it worked. Isn't that incredible? That's printed at 0.06 millimeters per layer, which is the highest quality these printers can work at. But that's incredible. That's a millimeter thick, that eyelid. So proof of concept. Oh, I was so thrilled when I saw it, especially having put the new printing head on, nozzle and things. I'm sure that's helped. So that's lovely. Proof of concept. So the next thing was to think about how to link the motor to the eyelids. Gears. I was thinking about drive belts and things like that. But gears just make the perfect thing because they're just sort of pushing, but constantly being able to push things, if that makes any sense. So I drew out the gears, imported DXF files of the gears that I've used before, and then I discovered that if you save them as a bitmap, white against black, you can then import them into 3D Builder, and it'll turn them into sort of extruded shapes, which is very handy. So that's the stage I've got to at the moment. Also, while I'm sitting here in the kitchen hunched over a hot 3D builder, I wanted to watch DVDs or television or films or something. I know that I could actually have a small screen doing it on that, but I just like to have the whole screen, or multi-screens or something or other. And I was looking up on Amazon, I got to the stage of looking up portable DVD players, and then remembered I had this beautiful old computer. It was the first laptop that we were given, teachers were given by the school I used to work at. Isn't that amazing? It's Windows 98, and I plugged it in, switched it on, and it started up. How fantastic. So the great thing about this, because it's an old computer, is that it can play DVDs. So I realised that's 20 something or other years old, 27 years old, older than my kids, and it still works. How fabulous. Heavens to Betsy, it's really small. I think I've lost the ability to relate dimensions in a virtual world to dimensions in a real one. That is really small. Oh well, fingers crossed. I thought it'd be nice to keep going with this video until it actually made something in the real world, and I have now done that. So I thought, being all optimistic, unlike me, that I would print the two outer pieces and also a little thing that pushes in to stop the ball bearings coming out all at the same time. Sadly, however, very quickly, because I didn't think to create a raft to fix the bits to the base of the 3D printer, the ball holder very quickly became detached. What a fool. Now I just left it alone thinking, well, you know, each time it did a slice, basically just end up with a load of little bits of spaghetti like that. I thought, well, that'll be all right, it'll just push it out of the way. Then 2.5 hours in, I noticed that in fact these little bits, the bits of floof, had started being pushed into this structure as well. I thought, nah, not with a ball race and things, so I cancelled it and started again. It was handy, however, because I realised or discovered that 0.5 millimetre gap round here really wasn't enough. So I changed that, to 1 millimetre and reprinted it. Oh, and before that, I thought, well, it's stupid going right for the really long-term print job. I thought I'd better just check whether one of these ball bearings would fit through a 5.2 millimetre 3D printed hole. And it does. Isn't that lovely? So I did that just as an interim little project, and then printed them, and then posted the ball bearings in. Oh, and look, dear friends, I'm just holding that in with a rubber band. Look, oh, I can't tell you how exciting that is, because I really didn't know whether it would work first time. At least there's virtually no slop that way. It doesn't move up and down at all. It spins beautifully, spinny things. There's the hole for the servo motor. Oh, absolutely thrilled with that. So we have actually achieved something. We've created something. That's lovely. So thank you very much for watching. Nice place to stop the video. Hope you found it interesting and informative. Hope to see you next time. I'll put links to my Etsy shop and website in the comments. Hope to see you next time when we're going to print loads more exciting stuff. I cannot wait. In fact, there is something very exciting printing at the moment. It's half the head. I can't wait to print the other bits and see what works, the jaws and stuff. Oh, I do like this project. Lovely.